Is anyone else hearing that noise, or is that just me?
Sorry, that's me. I was getting feedback. That's my.
It's that plane taking off.
Yeah, it was feedback loop. That was my on my end.
So leave the Discord chat.
Yeah, you can leave the Discord chat. Because we're gonna move over to YouTube Live. So I'm gonna sign off here, so I'm not getting a feedback loop from that. Can everybody hear me now? Oh, I need to move back over here because we're back on this camera. Cool. So one question had been asked in the on perusal regarding when to use Bootstrap Grid, when to use Bootstrap Flex. The answer is you really use both, and it really depends on what the particular situation is as to that. In general, I would say do your page layout, your large scale layout, do that using Flex. That's going to be kind of the way I prefer you to do that. And then when you get down to things like here are the products that are in my store, that's where I would start using the grid, specifically using rows and columns. That's I would do anytime I want to then have kind of content inside of the page that needs to be in some sort of grid. So the answer is you use both. The container class for sure. You remember there's a bunch of different container classes. There's container fluid versus there's container. Usually you'll want to use container at some point in there to make things not be the full width. So you may start with, here's your kind of outer level and series of sections from top to bottom, but then within those sections, you'll probably want to end up putting each of those sections inside of a container, which is kind of considered part of grid. But you don't necessarily have to be using rows and columns to be using that container class. So that container class is what's going to squish it out, where you would normally say, well, I want this to be 80%. That's where you use the container. Any other questions on Flex versus grid? Does that kind of help straighten some of those questions out? And if it looks like I'm looking over to my left a little bit, that's just because I'm watching the YouTube comments over here, and I've got my slides over here. Okay. So let's get into Node. Slideshow from current slide. There we go. Okay. So today we're going to talk a little bit about Node and how to get started with some basic applications. And then tomorrow we'll kind of continue this through this week and next, because there's a lot of little things that we need to hit on Node. So today we're going to start on Node. Tomorrow we'll talk a bit more about something called NPM, which is also kind of an important part. So first thing we'll go over is how to install Node.js. In theory, you've already done this, so this should go pretty quick because you should already have it installed, but we just want to make sure that we verify your installation before we get running and going further. So we'll make sure that we have Node.js installed correctly. We'll do a simple command line application. We'll do a simple web server, and then we'll talk a little bit about kind of writing asynchronous JavaScript code. And what that means, because a lot of things that we do this semester are kind of going to rely on that understanding of what that is. There's a few different ways to do asynchronous in JavaScript nowadays. Generally breaks down to the 3 different ones. So we'll talk about that first, and what those methods are, kind of in a quick overview, and we'll come back to those more as the semester goes on. So let's talk about how to install Node.js, and as well as how to install NPM. So Node.js and NPM are both really, really important tools that we'll be using for our projects this semester. They actually installed at the same time. So if you install Node, you actually have NPM as well. So you don't necessarily have to install both of those separately. It is possible to install them separately, but the normal thing that you'll get will have both of those things in it. So if we go out to the official website, which is nodejs.org, you'll see something like this. Okay, and there's 2 different versions available right now. There is either the LTS, the long-term support version, or there is the current version. The current version is the kind of bleeding edge version. It's the latest version that's available, but it may not necessarily be the most stable. Okay, so what we're going to be building on is the long-term supports version, which is considered the more stable version. So that way we won't have to deal with bleeding edge bugs as we're kind of working through this course. If you run into something, it's generally means that there's fewer bugs with this version than there is with that version, and it means that you're going to stumble over fewer things using the long-term version instead of using the current version. Questions on that? So I'm going to pull down, I guess really, if you have a question, just go ahead and put it into YouTube chat at any point, and I'll get back to it when I kind of hit it right where I can answer that. So let's look at the long-term support version. So I'm going to pull this down. Again, you've probably already done this, assuming you went through the install instructions. So we're going to pull that down. Once it finishes downloading, I'm going to click on it here. It's still verifying. There it goes. Okay. All right, so I'm going to pull this up. There's really not much I have to do. It's already been installed, and as you can see here, it's already told me there. As I remember, there aren't really any checkboxes or anything that you have to click. If I say maybe repair, we'll go back through this, and you can see if there's anything to click on, but I think that it pretty much is automated, if I remember right. There's no voice on this, so you'll just have to type. I can't hear anything you're saying, unfortunately. So, all right, so I've got that long-term support version installed. And then what I want to pull up next is either CMD or PowerShell. So you can do that in really any bashes. We can do the verification, but I'm going to pull this up in PowerShell. Okay, so I've got PowerShell up, and if Node is installed correctly, then I should be able to run a few commands. So I should be able to run Node-v. That will give me the version of Node I have installed. I also should be able to run npm-v to give me the version of npm that is installed. So I'm going to pull that in. I've got PowerShell open. I'm going to run both of these commands. Let me see if I can make this a little bit larger. There. So you can see what's happening with my command line. Okay, so first command is node-v. Okay, and you should have an output like that. So your Node version should be 12.18.3, and if you paid attention to the website, you'll see that's the version that shows up here, is 12.18.3 is that long-term support version. Okay, I also want to do npm-v to get the version of npm, and you'll see that those two are not the same, right? So npm, I got it installed already because it's part of Node. When I download Node, I also get npm, but it's kind of a separate program, which is why it has a separate version number. So once you get both of those commands run, would you please post the two versions that came into chat? You can use the built-in terminal as well, and we'll go over using the built-in terminal in a minute. It's just easier to verify this outside of Visual Studio, because then we can make sure that Visual Studio is not kind of contradicting or causing an additional problem with this. So both of these can be run through Visual Studio. It's just easier to kind of be sure and fix it if we need to, if we're not running in Visual Studio yet. On the difference for CMD versus PowerShell, CMD is an emulator for the old DOS terminal, so it's kind of an older syntax. PowerShell is kind of the latest thing for the newest version of the terminal for Windows, which has been available, I think, since Windows 7 or so. Possibly, I think, back to XP actually too, but definitely back to 7, and provides a lot more stuff that you can do. So PowerShell can do all of the DOS commands. It can do C# stuff, as well as it can do some PowerShell specific language. It's kind of got 3 languages in one, but it also in there, a lot of times you can write commands that would be for like a Linux bash and run those against PowerShell, and most of those will work. Sometimes with a little modification, but you can often run bash scripts, Linux scripts in here as well. Again, once you get these version numbers up, please post them into the chat, just so we can make sure that everybody's there. Now, Paul, I can see that you have the wrong version numbers just looking at that, and that tells me that when you installed, you went and got the latest. So you'll need to go install Node again to make sure that you're on the stable version, not the unstable version. Daniel, it looks like you're a version behind, so you want to go update that. Go out to the website and download Node again, because you have a 12.18.2, not 12.18.3. No, just download the new version and you should get an option to change or replace it once you run the installer. I don't think you have to uninstall before you put the new one in. You may have to, but I don't think you have to. I think it'll just let you say that I want to downgrade it. Okay. Yeah, so if that's what you're getting with the install, then you will need to uninstall it and install it again. Ooh, well that's odd, Daniel. I don't know what happened there. I'm not actually seeing it on my end. I'm not even seeing your post, Daniel, on my chat either. So I'm not sure what's up there. I might check if there is. I might have to look at that afterward. Chocolatey? I don't know what you're talking about, chocolatey. Anyway. So it sounds like most people are here. Has anybody, and part of what I wanted to make sure is that nobody had an issue actually getting PowerShell open. I think PowerShell nowadays ships as part of Windows, but it didn't used to. So I just want to make sure that everybody actually has PowerShell installed. Okay. So I think I've heard from everybody. Daniel, I heard from you in chat. So that's everybody there. So good. That helps. That makes sure that you actually have Node installed and NPM installed, and that we're kind of working at the same place. because there are slight nuances between different versions of Node. So if we're working with different versions of Node or different versions of NPM, then we may come into some issues where maybe it works for me, doesn't work for you, or maybe it works for you and not me. So if we're all on the same version, that'll help alleviate some of those problems. Okay. So first we want to do, first thing we're going to do is we're going to actually build our first command line application using Node. Okay. So what I'm going to do, first thing I'm going to do is I'm going to go to my desktop. Let me hop out of my slides here real quick. So I'm going to go to my desktop and I'm going to create a new folder. I'm going to call that new folder Node 1. So this Node 1 project, what we're going to put in here, this is not stuff that I need you to upload and get. It's just we're going to do some simple examples to just illustrate some things. So in this Node 1 folder, right, so I've got this Node 1 folder created. I'm going to actually do the rest in VS Code. So I'm going to close that. And I'm going to go into Visual Studio Code and do the rest of this process. So VS Code, pull that up. I can close down this PowerShell window now. I'm going to open the folder that I have. So on my desktop, I'm going to open up that Node 1 folder. Okay, so you should see that I have Node 1 opened here on my left. So the first thing I want to do in that folder is create just a simple JavaScript file. And I'm going to create this at the root. I'm not going to put this in a sort of JS folder because this will end up being JavaScript that runs on the server or runs on the back end instead of being JavaScript that runs on the front end, which was what we're familiar with. So I'm going to create a new file. We're going to call it simple.js. And I'm really going to not put very much into it. I just want to write in a simple logging statement. So I might write in console.log, and it could be as simple as hello world. So you'll remember we've written this before. We've written JavaScript that's running in the browser. What Node actually allows us to do is it allows us to run JavaScript outside of the browser. So up until Node was introduced roughly 10 years ago, I think 2010 was the original release date of Node, you could only run JavaScript in the browser. So what a really smart individual did said, hey, well, this Node engine, this JavaScript engine that's built into Chrome is actually really good and it's really fast. What if I could write other applications in JavaScript? So they took the V8 engine, which is what runs JavaScript in the Chrome browser, and pulled it out into this separate executable. So now I can write applications, not just websites. I can write applications in the JavaScript language. So that's what I'm doing here. So I'm writing console log. Remember that would normally go to your console window in your browser. I'm actually going to run this directly on the command line. Okay, so I've got my code in here. Simple.js just has this one line to console log. I'm going to open up a new terminal window, which is up here on the top. And say new terminal. And this is where we wanted to make sure that we had, Node, that we had PowerShell installed as well, Node installed. So I'm in the terminal here, and you'll see what folder I'm currently in. So the folder I'm currently in is in desktop, and it's this Node 1 folder. So it automatically opens up the terminal in our project directory. And that's important because if I had, say, open this to desktop, right, what would be my current directory here? Well, my current directory would not contain Node 1, right? So I need to make sure I'm opening to the right folder, otherwise, my commands are not going to be running in the right directory. Now, I can change that, but I would recommend making sure you start with the right folder, because that's going to make your whole process easier. So if I do want to navigate around in the command line, I can use the cd command, short for change directory. So if I do cd ... says goes up a level. So if I do cd ... you'll see that my current directory changes from being node 1 down to desktop. Okay, so that's how I can move up a directory. Similarly, I could move down a directory and go back into the node 1 directory. So I could say cd node 1, that will move me back down to where I was. Okay. Now, one useful command that you'll also want to know as you're navigating around here, you'll want to be able to list what's there potentially, to kind of orient yourself. So one command you can type in is ls, and that will give you a list of all the files that are there. So we can see in node 1, if I do s, the only thing that comes out is going to be that there is a simple.js file, right? That's the only full file I've created so far. I can also go back up to my desktop, and if I do an ls there, you're going to see that there's a lot more files you see on my desktop, right? So you can use cd and ls to navigate around to make sure that you're in the right place. Okay, so node 1. So the place I want to be is node 1, and I can type in cls to clear this out, so I'm back to the original. So commands you want to know, remember cd for change directory, ls to list the files that are there, and also to cls to clear the screen. So those 3 commands can be very helpful as you're working through this. All right, so now we want to actually run the program. So I've kind of shown you how to get around. We do want to actually run the program. So the way to run the program is I type in node first, right? Remember when I typed in cd and such, that's kind of the name of the command I'm running, right? So I'm running the node executable. And after that, I need to then tell it what JavaScript file do you want it to run. So we're going to say node simple.js. So what this is going to do, if I hit enter here, it's going to just go execute that simple.js file using Node. Okay, so we can see when I execute simple.js, you see it's running the code. It's running my JavaScript code, but it's basically running this as a command line application. Right? Remember, we taught you probably built command line applications back in your C# class, but you wrote them in C#, right? Now we're writing these command line applications in JavaScript. So just give me a quick say, hi, I'm here, or I got it working, if this is all working for you up until this point. That you've got it, you've opened up the terminal and you've run the node simple.js and you've got that output. So you can really build all sorts of applications using this. It doesn't have to be just web applications. It can be any. We can work with files. We can work with the console, as you can see. We can build all sorts of things. So This is a lot more expansive than even the things that we'll touch on this semester as far as what you can do with Node. But the thing we'll be focusing on this semester is building web servers, building web applications with Node. So we're going to use Node to build that back-end part that's going to actually serve our files and our connect those to the databases and do all that logic on the back end. Okay, so we've gone over how to do that. We're here. We've seen the output. So the next thing we want to do is I'm going to do another example, and we're going to actually build a quick web server. And this is one of those places that Node really shines, because building a web server sometimes can take a lot of code. You can write web servers in C, and people have, and people do. But if I write a web server in C, there's an awful lot of code that I have to write just to get that server up and running. So with Node, and a lot of more modern technologies have this advantage as well, I can get that server up and running a lot quicker. There's not a lot of code that I have to write to get a web server on with Node. Okay. So we're going to close simple.js. I'm going to create a new file, and that new file I'm going to call program2.js. Okay, so I've got program2.js. Now I've got it open. So in there I'm going to put a bit more code. A bit more code is going to go into this particular application than the previous one. I've got it kind of all on the slide, so I'm going to kind of type it in from there. So the first thing I need to do is bring in the HTTP library. So I do this like so. I think actually I will go ahead and copy paste all of this stuff into, I'm going to go and throw all this in Discord so you can get it quicker without having to type all of it out. And that should also prevent some issues as typing it in. So there's the code that you need. I don't know why that posted a screenshot. Oh well. Okay. So kind of running through line by line. Again, you can get this whole thing in Discord. I posted a copy there if you wanted to copy and paste it from there and not type all of it in. So the first line of code, this const require HTTP. What that says is I want to bring in the HTTP library, which is actually part of Node itself. It's already provided. HTTP provides a lot of easy tools for building your own web server. It provides everything you need to implement a server that runs over the HTTP protocol. If I wanted to build this for HTTPS, there's one as well. At that point, I need to use HTTPS library instead if I wanted to build an HTTPS server. But here I'm just going to build an HTTP server. Okay. The next thing I need to know is what port am I going to be able to connect to the web server on? Now typically if I'm running a web server in production, that's usually going to be over port 80. Port 80 is kind of that default port for serving up HTTP content. But as I'm developing, I often find that you need to run more than one web server in parallel, and if they're all running off the same port, then you're going to have issues because only one program can run on a port at a given time. Port is kind of a networking concept. To back up a little bit, you've probably heard of IP addresses already. Your computer, typically you can kind of think of it having a unique IP address. That's not really the whole story. More than one computer can have the same IP address, and it's also possible for your computer to have more than one IP address. So that's not entirely true, but you can think of it that way. So your IP address is kind of your way to get to your computer. And then to actually connect to your computer, you actually need a port as well. So to make any sort of connection over TCP, which is what we're doing, you need an IP address and you need a port, right? So you need the IP of your computer and you need a port number. And that port number tells you which application is it connecting. So that port is reserved for our application, so we know, hey, if I connect on this one, that will be where it is. So I'm going to add in another const here, a variable. I'm going to call this port, all uppercase, and I'm going to set this to process.env.port, or we're going to set it to 3000. Now you'll remember last week we talked a little bit about what this syntax is. So this is using that idea of falsy, which we talked about previously. So if this value is set, if this environment variable, right, which is the port, is set, that's going to be the value we use. And if that's not set, then we're going to use port 3000. Okay, so by default, our server is going to run on port 3000. I could write this just as such. I could say the port is it's 3000, right? But that means that then I'm going to have problems running multiple servers at once because, well, all the servers I build, all the applications I build, they'll all be trying to use port 3000. So I need some way for me to change and have, one application or another application running on a different port. Or I also need to be able to change it when I go push this out to the internet. I'll need to have it not be port 3000 when this goes live. So by doing that, putting process.env.port, first I'm saying use the environment variable if it's there as an override for that port 3000. Okay, so by default it's port 3000 unless it's set by an environment variable. Okay. Now it's worth asking, what is an environment variable? So an environment variable in general, is one that is a variable that's set across your entire system. So anything you put into an environment variable typically is something that anywhere on your computer you can get access to. You can get access to those variables wherever you're running code. Okay, any application on your computer can get access to those things. So it's kind of you can think of it as maybe more global variable that's even beyond the scope of your application specifically, that is set in your operating system. So Windows has this, all versions of Windows have this. Even going back to DOS, there were environment variables. Linux has environment variables, Mac has environment variables. The way you set them changes from operating system to operating system. So where you have to go and set it on Linux is maybe a little bit different versus go setting environment variables on Windows and Mac. So the process varies a little bit different from OS to OS. In general, if I'm using PowerShell. So let me actually close this terminal. So if I'm in my terminal here, I can look at some of these environment variables using the command get variable. So one common one that you'll probably have set is your path. Now I think I'm missing something. I think I want value only. Let's see if I have this right. No. There we go. Okay. So I can get for instance, the home variable, and that would give me where is the home of my user, right? Where is the root of my user? So there's a bunch of variables that are set, and you can look at those in PowerShell using the get variable command. I think if I don't include value only, there it'll list it as home and the value. Okay, so I can look at those in my shell, right? I can look at those in my shell, but I can't easily. I can maybe mess around and set them here. There are ways to set them over the PowerShell, but they usually don't stick. So what I want to actually do is go into Windows and show you where to change these environment variables. Okay. So what we want to do is we're going to go to our search here, and we're going to type in env. env, short for environment variables. So you're going to get a command that comes up like this: edit system environment variables. You're going to get that in Windows. We're going to click on that. Okay, and it's going to take us to this window. Now, this window you can get through other routes, and it's a little bit buried. You'll notice that we're in the System Properties window. We'll notice we're under the Advanced tab, but I don't immediately see an interface to edit the environment variables. So the place I actually edit the environment variables is down here. See, environment variables ... So I'm going to go under Advanced. I'm going to click Environment Variables, and that's going to bring up this window. Okay, so this window is where I'm actually going to set these things. So, for instance, if I wanted to set an environment variable, I would say New. This is going to create a new environment variable, and I need to give it a name and a value. Okay, so let's say I want to create. I'm going to call this variable test. And we're going to call the value, we're going to say this is test pony, right? So test is the name of variable, pony is the value, right? So test equals pony, okay? And then I'm going to hit OK. Now it's worth mentioning that there are, as you can see, there's two sections here. So there's a bottom section of this, and these bottom variables down here are system wide. But in order for these to apply, these require a system reboot. If you change any system variables, you have to completely reboot Windows for these to apply. This section over here says user variables for Paul Smith. This is only my account on this computer. So if I go to change this, I don't have to reboot the computer for it to apply these user variables. I only have to reboot an application. Okay, so by changing this, setting this up here, I'm changing it just for my user account, but I will have to reboot the application for that to apply. So I've got test pony in there. I'm going to hit OK. I'm going to hit OK here, and let's say we do get variable, and we're going to say let's get that test value. And let's see what we get. Well, it says, hey, that doesn't exist, right? So we can see that if I do get variable test, right, nothing actually happens. It actually doesn't find that environment variable. Okay, so if I want to actually have that have an effect, I actually need to shut down Visual Studio and bring it back up. Because that's kind of the core, the root application. Those environment variables only change when the application starts. So we need to go back into Visual Studio and change and try that again. So I'm back in Visual Studio. I'm going to call get variable and test. Okay. Now I think that maybe I'm not doing the right command here. So let me try, instead of doing get variable, let me pull up a command prompt and try it a different way. So echo %test. There we go. So if I do echo there, the syntax in PowerShell versus the syntax in there is a little versus the syntax in PowerShell is a little bit different. So I need to go back and look at what that is really. So you should see if you've set that environment variable, then you'll see it show up like this. And now I closed all my windows accidentally. Any questions right now about environment variables? People a few minutes to catch up. Okay. So this idea of environment variables, it's probably the first time you've run into it. They're pretty important as far as being able to actually deploy our applications, because when we go to deploy our applications, we'll need to have to play around with these variables to get our application to work. So things that you'll see, for instance, in environment variables like this are things like the port is one common one, but you'll also see like the connection details for your database. What's the username, password, and address and such, the URL and such that you need to connect to your database or whatever service you're using to send emails out. So do any of those things, we need environment variables to configure that on a per environment basis. Okay, so just to break down a little bit of what's happening here, because there's a few different words. So process refers to the running program. So our program here is program2.js. So that process that kind of the code is running into, that's what we're referring to as the process. Process refers to the running program. And that's a global variable in Node. You can get to that anywhere. env refers to the group of environment variables that are set on that process. Remember, the environment variables are set when the application starts. And then from there, I just do a dot with the name of the variable. So if I remember when I set that up, I set it up as test. So for instance, if I were to in here maybe do a quick console console.log and do that way. Process.env.test. So just log what that environment variable is set to. Then I would see here node program2.js, and it's not been set. Okay, well that's interesting. That may require some introspection, because that should have shown up as test, as pony. So I must be missing something. So that would be normally how I would get into it. Must be missing something. I don't know. I may have to do a Windows restart to forget that to apply. But typically that would be how I would log that. I know that I think I have a debug variable set. So let me try that. There we go. So I know my debug variable set. It must mean that I need to actually reboot the computer more to get back to that. I may have not let Visual Studio given it enough time to shut down. So that gives me a way to introspect those environment variables, is using process.env and then the name of the environment variable. Okay, so that's a lot to kind of explain that one line, because there's a lot of things going into just that one line of code. But that's how you want to work with anytime you have environment variables. You say get it, try to get it, and if it's not there, use this value instead, typically. Or you're just going to say, some settings you may not be able to default. You would just throw an exception. Okay, so we've got the port, we've got the HTTP module loaded. And here I want to say next, let's actually create the server. So const server is equal to http.create server. Okay, so create server says create a new server. It needs a handler. Okay, and what we refer, the specific handler that we have here, we refer to that as the request handler. It has two parameters, so it needs the request and the response. Oftentimes we'll write those short out as REQ and RES. You can also spell those out for better readability, which I usually end up doing, and writing them out as request and response. But most code examples that you'll see them written out as REQ and RES. But that's what they're short for. Okay, so it takes those two things in. The request is what's coming from the web browser. So when you go visit a page, it'll include like, hey, I want the picture of the puppy, or I want your home page, or I want your favicon. So that includes information about what resource the browser is asking for, and the response is what we're sending back. Okay, so if I want to send something back here, I need to do a few things. So first, I need to send some headers, and the way I do that is response.write head. Okay, so on the response, I'm going to write head, and this first number here is what we refer to as a status code. So status code 200 means that it's okay. Everything went through successfully. Here's a response. So we're going to say that this is successful. So we're going to send back a status code of 200. I'm also going to add in some additional information here, which is the content type. And we're going to set that to text plain. So we're setting the content type header, and we're giving it a value of text plain. And that says that the response that we're going to come back, treat that as a text file, right? If you had it on your computer, this would be a file with the txt extension. But because of how the web works, we have to, the browser can't actually rely on the extension of the file to know what kind of file it is. The browser actually, your server actually has to tell it what type of file it is. Okay. Now there are some ways, there's some tools that we'll talk about this week and next to make that easier, so it'll automatically sort of figure out those file types. But for now, this simple setup, I need to tell it what kind of file it is. Okay, so that's going to tell it that it's just a plain text file. All right, and the next thing I need to do, now that I've written the headers, I also need to write the content of the page. Okay, so the content of the page is just going to be the words "Hello World." Okay, so that's the text that we're actually going to see in the browser. And because I've told it to be text plain, it's going to look like a plain text file instead of looking like HTML, because we can also send back HTML, CSS. We can send back any file we want. But here I'm just sending it back, again, a plain text file. Okay, so that's creating the server, and there's the handler. That's the code that's going to run anytime the browser asks for a file. Is we're just going to come back and say hello world. And then to actually start the server, I've created the server, but it's not listening for connections yet. So it needs to listen for connections from browsers, and there it needs two things. So first it needs to know which port to listen on, right? Which is what we've defined up here. Is we've defined that we want it to listen on, whatever the environment variable is, or port 3000. And then I want it to do some logic when it actually starts. So once the server starts running, Then I want to write to the console giving me that info, that it's actually running. So we use console log. And in there I could just say, server is running. That would be the kind of the easy version. Okay. Let me start with that real quick. So I'm going to start with server is running. And let's try to start this up. So I'm going to say node program2.js. And you can see here, see how it's saying server is running? Okay, so it's up and running. But it's not really telling me anything about where it's running or what port it's running on for me to connect to, right? I can connect to it, but it's really helpful to know what port is it even running on. So I'm going to change the log message a little bit. So rather than using single quotes, right? I can use single quotes or double quotes anytime I want a literal. But here I actually want to give it, I want to combine in the port number. So I could say like this, server is listening on port, right? And I could do this with string concatenation like that. Right, so I've saved the code. Now it's worth noting, my program hasn't, I've changed the code here. Notice nothing's changed, right? The program's still running. So I actually need to stop my server and restart it, okay? Now the way you stop your server is you do you go down here, get focus on your terminal, and you're going to do Control C. Control C will stop that running program, okay? I'm going to go back up arrow, run that command again. Now you can see that it's saying server is listening on port 3000. Okay, so you can build out messages like this using concatenation. Okay, using that plus operator. That gets very messy quickly. Using plus for concatenation can very quickly get messy because you've got these long sort of expressions and you kind of lose where. There's a lot of extra characters that I have to add in to put things in there. And it also can be an issue because remember, anytime you use plus, well, plus means two things. Plus means either concatenation or it means addition, right? So it's actually better for me to use what's called a template string. So a template string is a relatively new feature in JavaScript. And the way you write a template string, you have to start and end the string with a little caret. If you're looking on your keyboard, that will be the top left key. It's right next to the 1 and the tab key. That's where you'll find that. That's this little exclamation mark, or not exclamation mark. This little caret or whatever. So that's the mark that we want to put there instead, at the beginning and the end of the string. Once I've done that, I can then put in placeholders. Those placeholders are started with $sign curly brace and end with curly brace. So between there, I can actually put any JavaScript I want. So I could just put in 3000. I could just put in a number. But here specifically, I want to put in that port variable. So what this will do is it'll start with what I've specified here is the template, and fill any placeholders with the variables we tell it. So if I stop the program again using Control C and restart it, see, you'll be saying the same thing. Server is listening on port 3000. So Daniel, you'd asked a question, what's a server effectively? I say, I'm creating a server. Yes, sometimes when we're talking about servers, we'll talk about those as machines or computers. And you hear that mostly from IT. If you're talking to somebody that's in IT or networking, oftentimes when they're talking about a server, they're talking about the computer. But here I'm talking about server in the sense of a program. I'm talking about this running program is my server. And that's kind of important because I can have a server machine that's actually running 10 different web servers. So I can have server applications, but I can also have server machines. And so a lot of times people will use the term server in place of server machine, or server as a program. Those terms often get used interchangeably, even though they're two different ideas. Okay. So that's how I want to write that template string out. Let's see what this actually looks like in the browser. So I'm going to open up a new window here, right? So remember, we're running on port 3000. What I want to type into the browser are going to be localhost. Okay, localhost refers to my machine. Okay, so localhost is always the computer that you're on. Okay, so we're going to say localhost and then colon 3000. So I'm saying connect to localhost, connect to myself, and access port 3000. There we go. There's my hello world server. Right. So I told it to write out that the text type is plain. So that's why you can kind of see it's showing up as courier new. If I were to inspect this, it looks like it's actually turned it into a web page, but it's actually technically rendering it as just a plain text file. But there's actually, let me go back to inspect, shows the HTML tags. But if I go to sources, there we go. So you'll see that there's actually no HTML tags there. It's just the words hello world. Any questions on that basic server setup? So the server machine actually hosts your program. Your program is the one that serves up the files. Program itself is the one that serves up the file. The server is just a computer that runs your programs. Yeah, I'll try what Troy said. Okay, let's give it a few minutes. Yeah, let's go ahead and take a 15-minute break here, and we'll come back at 2:20, and we'll go on to the next piece. If you have any questions with the material so far, please post them into the YouTube chat, and I'll answer them. I'll try to answer them as soon as we get back from break. So take a break until 2:15, or sorry, 2:20. So welcome back. We'll give everybody just kind of a minute to come back in. If you're back, please post something in the just post something in the chat so I know that who's here. All right. So with that kind of, welcome back from the break. I should probably start there. With this kind of setup, we just 10 lines of code. Yeah, I can see that, Darnell. So with just about 10 lines of code, we have created our own little web server, right? And we can actually serve anything we want using this. Now, one thing you might notice, one thing you might, if you've played around with the web server at all, you'll notice, okay, I went to localhost 3000, right? And I did get hello world, but notice when I wrote that handler for the request and response, right? I haven't told it to look at anything in the request. So what that means is, regardless of what sort of resource I asked for, I'm always going to get back this hello world. So for instance, if I type in /test, well, I would expect to get a different response, right? If I type in, My Little Pony, right, I would expect to get a different response, right? So the server I've built so far isn't maybe all that useful because it always gives me back the same response. Now, I can improve on that a little bit if I look at the URL that user asks for. So specifically, I want to look for, what page has the user asked for me to send back. So what I'm going to do in here is I'm going to say, well, let's say if the page that they ask me for is the root or the home page, and the way I can find out what they're requesting is I can look at the URL. So let's quickly log, before I put in the if-else's, let's log that out. So I can say console log, and let's log request.url. Okay. So I'm going to put that line of code in there. And here's one thing that you want to pay attention to as well. I'm going to go ahead and refresh the page. Let's refresh the page. You'll notice that nothing's actually being logged here, right? Because the change I just made to the code doesn't apply immediately. And I'll talk about how to make this work with a much better workflow tomorrow. But the way this is right now, I need to actually stop the server and restart it every time I make a change. So now that I've stopped it using Control-C and started it back up, now I can refresh it, and now you'll see that it's logging out the paths that were requested, right? So this URL, first of the time, we can see that just slash was given because it was requesting the home page, and then you can see I'm also requesting favicon.ico. Okay, what happens if I request test? Okay, then I can see what's requested is /test, and again, favicon.ico, right? So it's every time I request a page, it's actually requesting this file, as well as the page that I request. Okay, so I can use what I've seen here to kind of start making it give different responses. So in here, I'm going to say if request.url is, if this is equal to, if this is slash, then I want to say let's return hello world. Okay, and what I'm going to do then, I'm going to say else if, so if I get a different path, so let's say I get that test path. Let's say if I get test, well then I want to return something different. So I might say let's send the same headers, but we'll say test passed. Okay, so I can say, okay, if you ask for the root, we're going to say test passed, and then otherwise I need to also catch that else, right? So if it's anything else, commonly what you're going to want to send is send a 404 saying that the page is not found. So if they request the home page, we're going to give them back hello world. If they request test, then we're going to give them back test passed. And otherwise, if they ask for anything else, we're just going to say it's not found, right? And we're going to come back with a 404 error code instead of a 200 OK. Right, so again, I need to kill the server, so I'm going to do Control-C, kill that, and then I'm going to say run it again. Okay. So if we look at this, I'm going to go back to the home page and ask for it. Okay, so if we ask for the home page, we get hello world. I ask for /test, I get test passed. Okay, good. And then if I ask for anything else, say favicon.ico, right, I'm going to get not found. Right? So I can use, I can take a simple pattern like this and then start to say, well, depending on the criteria, depending on the URL that you ask for, give it back a different response. Now, over the break, Troy had asked, you know, we're working with this code now. Is this considered back-end code? And this is. The code that we're writing here would be considered the back end of our web application. So this is where we're writing the back end, and we're, as you can see, we're writing it in JavaScript. Technically, you can write backends in almost every language. You can write backends in Java. You can write backends in PHP. The way that you work with it is different from technology to technology, but that's what we're building this semester. Is we're going to build our backends with JavaScript, and that's become one of the most popular ways to build those backends today. It's changed over time. When I was when I was starting to build applications, we used a lot of static applications, and then for a period of time, PHP was the thing, and then there was Ruby in there, and C# and ASP.NET was a popular technology, and so it's changed over time, that specific technology that we're using on the back end. But the one that's become really, really popular with a lot of companies today is to use this thing called Node, because it provides a lot of benefits, and it's really good with working with something we call asynchronous code, which happens a lot. There's a lot of asynchronous code when you're working with a web server, and we can get a lot of benefits out of that. So that's our basic server. Are there any questions on this so far? Any other questions? Especially on what I just did with the different paths, the different routes. I will mention that while we can build servers this way, how did I test the path for test? While I can build servers this way, I don't usually. We're not going to end up building servers exactly this way. There's some tools, again, we'll talk about this week and next week, which will make this whole process even easier than what we see here. So the way I tested for test is I just typed in localhost 3000/test. I just typed that into the browser. So just by visiting that URL in the browser is how I got to test. So jumping back into my slide, we've looked at and run through my slides. We've run through some of this already, so I just want to review. So kind of working from the top to bottom, we saw how to start that. You start with Node and then the name of the script you want to run. You can see that in the browser. Here we're running on port 3000. That doesn't have to be port 3000. It can really be anything you want. But that's by that second line of code. Okay. So that first line of code, you'll see this a lot. You'll see this word require. Require is a function. It's actually a global function. And you're saying, here's something I want to bring in. And anytime you do require, you typically want to then save that to a constant variable. You're going to save that code a constant variable because then you need to refer to it. You use that code you just brought in later on in your application. If you're familiar with other languages, this is kind of like your import. If you're familiar with maybe C# with Java, this would be like an import. If you're familiar with C# the most, this would be like your usings that you have up at the top of the file. This is just the way you say what libraries or what things do I want to bring in. Okay. So these things we can bring in, they may be our code files. They may be code files that are part of the node itself, or they may be packages that we pull down from npm, which we'll talk about tomorrow. So there's a lot of different things that this is just bringing in other code that's in a separate file into our application. You always want to make sure that that's const, because you don't want anything to then be able to go change that. Go say, okay, well, I loaded in HTTP, and then I don't want to have like the next line be, okay, I loaded in my fun module and then called it HTTP, right? I don't want to change this. I definitely want to be const. So sometimes when you're looking at packages and things like this, they may suggest using the word var, or you may see, well, you could put var or let here. Absolutely. If you're doing a require, this should be constant. Okay. We talked about The next line, that's bringing in from the environment variable. If it's not set, we're defaulting back to 3000. Remember, the order of those is important. If I say 3000 or process environment port, if I swap the order of those two, then it's just always going to be 3000 because 3000 is not falsy, right? The reason that it works is because if port is not set, then port is empty string. And so empty string is falsy. I use the second value. We talked about creating server. That's the one that actually creates it. Sets up the handler. Talked about 200 is status code OK, and then it's plain text. And then the important thing here is the new thing is that template string. And I think that somebody correctly mentioned on Perusal that there is something in C# that works very similar to this. There are template strings now in C# as well, but they do have a different syntax. So just be forewarned with that. The syntax for template strings in C# is not the same one that it is not the same as what it is in JavaScript. So the important thing to remember is those tildes at the beginning and the end. Okay, so let's talk about asynchronous JavaScript and what does that mean? Because that's probably the most important thing and the most valuable thing to understand about Node, because that's what Node does really amazingly well. You can write asynchronous code in other technologies. The newest versions of ASP.NET do support asynchronous code. And most other technologies, so this is not an exclusively JavaScript thing, but it is something that JavaScript, and especially Node, does really, really well. So let's talk about what it is and why we want to use that. So traditionally, kind of explain what the term is. Traditionally, our code is written in what's called synchronous programming, right? You kind of hear the base in there, asynchronous, synchronous. The base is this word sync, right? You know, the idea that things need to happen in sync. And that generally means that things need to happen in order. If you're writing asynchronous code, it's always going from top to bottom, right? You can kind of think of it that way. You write line 1, it executes line 1. Write line 2, it executes line 2, line 3, line 4, etc. It's kind of working through your code from top to bottom, and it's always in that order. Okay? There's never a case, at least in theory, where two lines of code are executing at the same time. It's always line 1, line 2, line 3, etc. Now, you know, obviously you have loops in there, so it'll kind of go back and run it again and run it again. But the idea with synchronous is really that idea that only ever one thing is happening at a time. And that's reasonably easy to reason with. You can say, okay, well, this happens, and then this happens, and then this happens. That's pretty clear. But what it leads to is it leads to a lot of waiting, a lot of time that is wasted, because we're saying, okay, I want to go read this 1 GB file from the hard drive, and I tell my code to go read that file, right? And then I just say, okay, while that's happening, I'm not going to do anything because my next line is I need to use that data, right? So I read the file, and then my code just sits around and waits. Well, the problem with that theory is, let's say, okay, I want to go load that 1 GB file. Maybe it's a video file or just a really, really big image or whatever it may be. While it's loading that, my program can't do anything else. So if that takes 15 minutes, my user can't use my website for 15 minutes. Right? It also means if my request, if me handling one user takes a minute, well, I'm only handling that one user for that minute. I can't handle other users at the same time. So that becomes a problem because, well, that's, again, it's a lot of wasted time. So the idea here is as long as that code is running, again with synchronous code, is you're going to say that, well, the program stopped. Until I get a result, right? Until that equals comes back and says, I say that, you know, this is text of file equals read file. well, until read file finishes, then I can't use that text. So I have to wait for it. And so we call that synchronous programming. The idea of sitting around and just, running from top to bottom, only one thing happening at a time. That's what we get. And it's really just, it's going to lead you to, if you can write code that way, and we used to write web servers that way. If you write old C#, ASP.NET websites, that's, especially if you're writing with forms, that's the kind of experience that you get. That experience that your web server is only ever handling one client at a time. Which the way we used to handle that is we just say, well, okay, well, that's slow. Well, let's just spin up a bunch of web servers, right? So one server can only handle one server application can only handle one user at a time. Well, let's just spin up, 16 of those, and then we can handle 16 clients at the same time. But then that creates additional problems and additional load, and now you need more hardware and more computers. So what we do instead with Node is we say, well, there's all this time that's being spent doing nothing, right? There's all this time spent waiting for files to load, or waiting for the database to come back with data, or all these kind of things, or waiting for another service. Maybe we need to get data from another website. All of these things, we're waiting for it to get done before we can move on to the next step. And maybe instead I can use that time in between when my code is just waiting to answer the request of another user. So rather than answering just one request at a time, I want to answer multiple requests at the same time. Okay. So that's my goal. So by allowing things to happen at the same time, I'm going to end up in what's called asynchronous programming. And what that effectively means is I kind of say, rather than immediately going, maybe going from line A, line B, line B, line B, line C, line D, etc., rather than going through the lines from top to bottom, I say, well, okay, I want to do this, and then let me know when it's done, right? Let me know when that file has been read, and then I'll go do it. Or let me know when the data from the database is available, and then I'll go do the next thing. Okay. So to do that, we need kind of a foundation that allows us to write asynchronous code. And so Node provides that. Node provides that with its APIs and with all the tools in the language that are there. Okay. So JavaScript is kind of our underlying technology here. JavaScript actually provides a few different ways to write asynchronous code. One way is through callbacks. This is the kind of the basic way that you can write asynchronous code, and we've actually already done a little bit of that. If you think about how do I hook up code for when a button's clicked, right? I say, well, when the button's clicked, I say go run this handler, this event handler. Well, that event handler is a callback, right? That function doesn't run immediately when I write it. It runs when the user clicks the button, when an event occurs, right? Or if I say when the form is submitted, go run this code. Well, that's an event handler. That's a callback. So I'm saying, in the response to the form being submitted. Or I could say in response to the form being reset, same kind of thing. That's another event. So this idea of callbacks is very, very much synonymous to actually what you're familiar with in terms of listening to events on the front end. Okay, so writing a click handler is very similar to what we're doing here. So if I look at my code, for instance, even just the basic web server that we've already written, I actually already have some callbacks in there. So my first callback in there is this code right here. I say, create the server and give it this handler. I say, call this code when the user wants a resource. When the user makes a request to my website, run this code. And I'm also giving it another handler here, another callback, to say when the server starts up, when it's actually running, run this code, right? So run this code when the server starts, and run this code, run that callback anytime that the user requests a resource. So if I look at how this code runs, it doesn't really run from top to bottom, right? It doesn't really run from line 1 down to line 21. It actually runs out of order. Namely that this function runs, anytime the user, anytime the user requests the resource. So the way it will turn out is it'll run line 1 through 20, and then it'll come back, the parts in the functions. I can kind of collapse this here. It'll run it through and run that, and then when it actually starts running, when the server starts running, it'll run this. So things that means, let me say I stop my server here. If I were to say console.log and I say let's write end of program, what I'm going to see is this end of program actually is written before it says server is running. Okay, so I'm going to save this. I'm going to run the server again. And so what you see is that, right? So end of program runs, and then server is listening on port 3000. It's not running from top to bottom, right? So this happens first, and then when the server actually starts up and is going, then this is called, right? So I finished running this file, but my program is still running, right? And then this code hasn't even run yet, right? That handler that I gave to create server doesn't run until I go to the browser and I ask for something, right? And in fact, it doesn't just run once. It runs every time I hit refresh or every time I put in a URL into the address bar, right? So can you see how that is? I've already got asynchronous code here because things are not happening in sequence necessarily, in the sequence that I wrote them. So callbacks is that basic version of asynchronous code that we can write. That's the first and simplest version. We can also write asynchronous code using something called promises in JavaScript. And promises are actually easier to work with in a lot of ways than callbacks. And then there's a third way that we can write asynchronous code, which is async await. And async await is then further simplified over promises. So as far as simplicity goes, callbacks are kind of, you're probably the most complicated way to write it, promises, and then async await. But each of these is based on the previous thing. So to really understand promises, you do have to understand callbacks. To understand async await, you really do have to understand promises, because you have to kind of work with all these things together, as it turns out. Okay, so what is a callback? Okay, callback is a function which is called when an asynchronous operation is completed and the result is available, right? So we've seen two callbacks already, right? We've seen a callback when the server starts running, and we've seen a callback when the user asks for a resource, when they make a request to our server. So let's back up a little bit and look at another example of a callback. Okay, so here I have a relatively simple application. I'm going to create a function called getToDo. Okay, let me actually bring up this code example in VS Code so I can run it. So I'm going to go to File, Open Folder. I'm going to actually go over to my code here, base node curriculum, unit 1, example. Oh, no, I want slides, examples. This is async. Yeah, there's where I want to be. So in this case, with callbacks, I'm going to say node and execute callback.js. Okay, so you can see as I ran it, I need to make a quick fix on the code. And I think that I also need to update that on the slide. Yep, I do need to update that on the slide because I made a change and I apparently did not update the code in the slide. So I'm going to create this function called getToDo. Okay, and I'm using this arrow syntax. We've kind of talked about this a little bit already. So it takes in a callback. That callback is a function. So it takes a function, and then here's what it executes. So I say set timeout. Remember set timeout, you probably encountered it in your first semester, is a way in JavaScript to say, I want to run something later. Okay, and so I'm using that to introduce a delay. So specifically I want in here, I want it to say, okay, let's go, and then 2 seconds later, we'll execute this code. So I'm setting a timeout to say I want something to happen not immediately, but I want to happen at a later point in time, which is an easy way to kind of emulate things like reading files or accessing databases, to introduce some kind of delay in there to see what would happen. So I'm saying set a timeout, and it's going to call this function here after 2,000 milliseconds. So 2,000 milliseconds is 2 seconds. So after 2 seconds, we're going to call this function. Okay. So when I call this function here, we say, okay, it's got no parameters, and it calls the callback, right? So getToDo says after 2 seconds, we're going to call the callback and pass in this value here, complete code example, right? So you can kind of think of this as going to a file and spending 2 seconds reading the file, and then when it gets done, it reads out this text, complete code example. Okay, so that's our getToDo function. Okay, and then here I actually call getToDo. If I didn't call it here, I'd just be defining a function, right? So if I just had this, just defining the function but never actually calling it, you see my program would exit immediately because there's well nothing to do, right? Defining a function doesn't actually cause the function to be executed. So I define the function and then I call the function. Okay. Now when I call getToDo, remember getToDo needs a callback itself, right? It needs a function to call when it's done. Okay, so what do? I say, well, when you're done, take the text that you gave me, right? Call that to-do, and then log it to the console. So this says my callback is that whatever I get back, I just want to write that out to the console, right? So this function gets called when? This function doesn't get called immediately. It gets called after 2 seconds. So I call getToDo, that sets a timeout, and then 2 seconds later it will call this function here, which that then calls the callback, which then calls this function here. So one of the things you'll definitely notice if you pay attention to that, you'll see that everything's kind of, well, it's not really in order at all, right? I can't just read the program from top to bottom and know what's going on. I have to kind of jump around a bit. So the idea with these callbacks is we're giving it a function to call at some later point in time. Again, you can think of that like an event, right? I can think of this as I'm saying, run this code when the user clicks my button. Any questions on callbacks? So this, remember, this is a way of defining a function. So this is a parameter, right? This is the name of a parameter to the getToDo function. So the getToDo accepts a function as a parameter, and we'll call that function later. So this code, I'll give you, actually if you look in the live stream, you'll see, if you look in the description of this live stream, you'll see a link to GitHub that contains the updated slides as well as the example code here. So that's how we can do things with callbacks. Okay. This can work, and you can technically write anything this way, but it gets very messy, very quickly. And part of that is you always end up calling callbacks from callbacks and nesting functions deeper and deeper and deeper. And as you nest functions deeper and deeper, you get into what we call callback hell, right? And callback hell is where you like, okay, I've got this callback up at the top, and then I've got callback, and then I'm like 3 to 5 levels deep, and it's like, okay, where am I, right? So this works, and it is really the underlying fundamental piece to all of our asynchronous code. It does come back to this, but writing code this way is actually really hard. So we want to make that a little bit easier, and try to make it use some tools and some tactic things to make it easier to read this code from top to bottom. Okay. So the first tool that we want to go over is something called promises. And promises are a built-in feature in JavaScript that makes dealing with asynchronous code easier, makes it more readable. So it's a language feature. It's something you have to have available. So on the back end, that's really easy. Node 12, Node 14, all of those have support for promises. It's worth noting not all browsers on the front end, not all browsers support promises fully yet. So promises work just fine on the back end. You may or may not have support for promises on the front end if you're writing this as front end JavaScript. So that's kind of still a little bit hit or miss. So you may still be stuck using callbacks on the front end. But most browsers are kind of moving that way to all supporting promises, except for obviously IE, which is older. So here we want to go over an example of how I might do the same thing but use a promise. Okay. Now this example is still a little bit more complicated than what you'll usually see, because usually whatever API that we're using is going to go ahead and give the promise to us. Okay. So the idea with a promise is it resolves in one of two ways. It resolves successfully or it resolves unsuccessfully. Okay. So the promise is either resolved with a successful response, or is it rejected and there's a failure. So you can either have the promise is I promise to do this, but I'm going to not do it. I'll do it eventually, right? And when I eventually get it done, then I'll let you know, right? So a promise object, okay, is kind of a wrapper around callbacks. And usually I'm going to get this from the API itself. I think I jumped ahead. Usually I'm going to get this from the API itself, but sometimes I may have to create these promises myself. So here I'm saying I want to wrap the set timeout function, which doesn't have a built-in way of doing promises, but I need to turn it into a promise. So I'm having this promise constructor. I'm going to say, let's create a new, this is inside of a function, but let me work kind of inside out. So I say, let's create a new promise. If I want to create a new promise, that needs to then take a handler. Okay, so that new promise needs a handler of some sort. That handler needs to take 2 arguments, resolve and reject. Resolve and reject. Resolve is a callback, reject is a callback. So if this operation that I'm performing, if it resolves successfully, then I'm going to call resolve and pass in the results of the operation. If it fails, then I call reject and I pass in the error. Okay, so I'm either going to call resolve as if it's successful or reject if it fails. Well, in the case of set timeout, well, set timeout never fails, right? It's only gonna succeed. I can't get an error with that. So I'm only going to call resolve in this case, but usually if you're using this promise constructor, you're going to have a reject case. So I'm going to say, let's say, okay, I pass in the handler, and I'm going to say set timeout. When the timeout expires, then we want to call resolve to say the promise has successfully resolved. Okay. Another thing I need to pass in here, remember set timeout needs not just the callback, but it also needs a delay, right? So I need to specify how long do I want it to wait. Okay, so I've got this variable here called delay. That's how many milliseconds it'll wait. That's actually a argument to this function we're in. So we have a function called wait. Maybe I should look at this in VS Code so that we've got some syntax highlighting. I've got this function called wait. And I need to zoom in a little bit. So I've got a function called wait, and that takes a delay, and that's the delay I'm going to use for set timeout. So I have wait, which returns a promise. Okay, and when that promise is kind of got the set timeout logic in there, so when it resolves, it's going to just call the resolve method. Okay, so then I'm going to use this. So this wait you can kind of think of as maybe a little bit of a black box. The idea is it's a promise that just waits a certain amount of time, and then it returns. Okay. So let's change up get to do to use this promise instead of using the callback that I had previously, right? So previously the get to do had this callback and timeout logic mixed in. Now I've effectively extracted the logic to wait to somewhere else. So get to do calls wait first. It says I want to wait 2,000 milliseconds. I want to wait 2 seconds, and then I want to do something else. So when I'm dealing with promises, anytime I have a promise, I don't say, well, assign that to a variable or do that first. I say do this, and then I chain the next operation to it, right? So I don't write this as you might be familiar with in synchronous code. I'm not going to write this as wait 2,000. And then, if you were thinking this strictly from top to bottom, you might think of this as let's wait first 2,000 milliseconds and then return this. Because this is asynchronous, this line of code and that line of code, they just run top to bottom. It won't actually wait 2,000 if I write it this way. So I need to tell it, run it at a later time. Don't run it immediately. So that doesn't work. It's just worth noting. So what I'm saying is do this, and then when the promise finishes, call this other callback. So wait 2000, and then evaluate this. So then says, okay, go run this function. This is my callback. Remember, this is short for a function that takes no parameters and returns complete code example. With me? Wait 2 seconds, and then effectively return complete code example. Now, remember, wait returns a promise. Then is a method on a promise, and then always returns a promise itself. So I'm saying promise, and then let's create another promise using the first promise. Okay. So that will end up returning this effectively. If I were to take the result of get_to_do and assign it to a variable, I would find that get_to_do returns a promise. It doesn't return this text. Okay. It returns a promise. It doesn't return that text. So I need to then say, if I want to get the result, if I actually want to be able to do something with the result, I need to stack another then on there. So I say wait 2000, then return this, and then I'm saying get_to_do, which runs both of those things, and then log it to the console. Then log it to the console. If there's any errors along the way, then I write a catch and I say, let's log that error. So let's say I run this. This is promise.js. So I'm going to say node promise.js. So you can see all it's going to do is going to wait 2 seconds and then print out the log, just like the previous example. Okay. This may seem a little bit obtuse, at least at the moment, and that's okay. That's okay. This is going to take a little bit of time to sink in. But as you kind of get used to it, you'll find that this syntax is a lot easier to work with in the end than the callback syntax, because it ends up working a little bit more top to bottom. It's not really top to bottom still, but it looks more like it. Okay. Are there any questions here about promises? Yeah, it'll take a little bit of time to sink in. This is something you'll have to read a little bit. Yeah, so all the stuff that's on, we're doing a live stream and it'll be available as soon as the stream ends. You'll be able to go back and replay it. So again, it's going to take a little bit of practice to get this. I would say that, my expectation is for you to first get experience and kind of understand the callback approach, and then to kind of step up to the promise approach and start to understand that before finally graduating to the async await approach, which I'll briefly go over here what it is, but I think it's definitely something we'll have to come back and revisit. So with the async await syntax, so remember, part of the goal of the promises is to make it so that you can read the code more from top to bottom and kind of hide some of these asynchronous issues. And get back to synchronous code, because synchronous code is kind of easy to read, right? It's got the problem that it's slow and it's not really efficient, but at least it's easy to read, right? So what I want to do is I'm going to then wrap another layer on top of on top of promises and make it look like I'm writing synchronous code. Okay. So in order to use, this async await syntax, so it says async functions let your programmer write promises base code as if it were synchronous, but without blocking the execution thread. So remember, normally with synchronous code, we're blocking the execution thread. But if I write it with async, it looks like it's synchronous, but it's not actually. It's actually asynchronous. So it operates asynchronously using promises. In order to use this await async task, await async, the async await method, you have to have promises already. You have to have promises coming from your API. Okay. But as soon as you have that, then you can use this. Async functions will always return a promise. So if I mark a function as being asynchronous, it will always return a promise, regardless of what is in there. And the await operator then I can use inside of that asynchronous function. I can't use the await operator outside of an asynchronous function. Okay, so this is what things look like if I use the async await syntax. The first two lines here that we see, I'm creating this wait function. This is exactly the same wait function that I saw previously. Again, that's the part that you usually won't see. That part of me creating the wait function is usually something that will be already provided by the API that you're working with, whether it's working with a database or files, that will usually be provided to you. And then we just use it. Now, I'm going to define the getToDo function, and I'm going to define it as async, right? So if we looked at the previous example, you see that I don't have any sort of keyword on the getToDo. It's just a normal synchronous function, which means I can't use the await operator. So what I'm going to do is I'm going to change it. I'm going to change it to be asynchronous. I'm going to change this function to be an asynchronous function. The previous one was, it just didn't have that. It didn't allow me to use the await keyword. Okay, so I'm going to make this function async, and then that allows me to use await here. So if I call wait 2000, remember wait returns a promise. The await operator then kind of unboxes it. It says, let's wait for the result of this promise. Okay, it says wait for the result of this wait promise, and then when it's done, okay, give me the result of that. And I can then, if I wanted, if that said maybe it returned a result, I could then put that into a variable. But in this case, it's not returning anything. So I'm just going to say await it, and then we'll run to the next line of code. And this may look like it's synchronous, because it may look like, well, oh, I'm sitting around and doing nothing. I can't run this line of code until that first one runs. But the reality of things is actually underneath with this syntax, it still lets other things happen. Okay, it still lets things go on while this specific function is waiting for that result. So I say await, and that says don't go to the next line of code until that happens. So wait 2000 2000 seconds, wait for that result, and then let's return complete code example. So wait 2000, complete code example, return that. So that's how I would implement that function here. And that's actually literally the same as what I had previously. It's just using a different syntax. So my previous syntax here, I said wait 2000 dot then do this, right? So with the await syntax, async await syntax, it looks like this instead. Okay. Now I do need to call getDoDo. Remember, if I don't call getDoDo, then nothing happens. So we're going to call getDoDo, and I'll talk about some of the skeleton around here of what's happening in a moment, but let's just look at what's inside of the try. So inside of this try, I'm saying const to do is equal to await.getToDo. Await getToDo. So getToDo is called. Remember, it returns a promise, which we'll evaluate at a later time. In this case, it's 2 seconds later. So 2 seconds later, getToDo returns the result. I'm using the await operator to say wait until there's a response from getToDo, until that finishes. When that finishes, then we'll save it to this to-do variable, and we'll go on. So I'm saying get that, wait for it, and then finally log it. Now, I've also got a try catch around here. If I'm using this await syntax, rather than using the dot catch, I use this. I actually can go back to using try catches. And so this says if anything goes wrong in here, let's say a promise is rejected, that error is then going to go down to the catch here. Okay. So I want to use a try catch anytime I'm using the wait operator. So I say if something goes wrong, we'll log it to the console using console.error. Okay. So that's my try catch. And now there's something weird happening with the stuff around it. Namely that in order for this to work, in order for me to use the await operator, I have to be in an asynchronous function, right? So in order for me to use the await operator, I have to be in an asynchronous function. So I have to create a function here that is asynchronous, because just writing things directly in kind of the root context, that's just synchronous. I can't use the await operator there. So I have to create a function, and then I have to call that function. So this part in here with these inner parentheses, the parenthesis starts here, parenthesis ends here, that I'm defining a synchronous function. And then these two parentheses here, I'm then immediately calling that function. So I declare a function, an anonymous function, and then I immediately call it using the parentheses there. That structure of creating a function and then immediately calling it, that's what we call an IIFE, an I-I-F-E, IIFE. That's short for immediately invoked function expression. And you can follow the link here. There's a whole article about what that is, but immediately invoked function expression is what that stands for, what that acronym stands for. So that's a common kind of JavaScript trick that's used for a lot of things, but specifically you need it here if you're going to call an async function from the root context. So this is kind of a weird case. Again, I expect that we're going to have to go through this again. This is probably a little bit too early to touch on these things, but at least get your some eyeballs on it right now. Okay. So let's just a refresh on what we talked about today. We talked about briefly how to install Node.js. We talked about how to download it from the website, and then we also talked about how to verify that it's installed correctly using the node-v and the npm-v commands to verify that your versions are correct. We created a very simple Node.js application. You saw how we could write just simple console applications. We can write using Node.js, writing JavaScript outside the browser. We saw an example where you could build a simple web server just using Node.js. We also talked a little bit how to write and work with asynchronous code using either callbacks or promises and async await. Again, these are things, asynchronous code is something we're going to have to talk about again throughout the semester because, it's one of those things that just takes some time for, it takes some time for it to sink in, to get it to being something that makes sense and you understand. So what I would focus on right now is really understanding how that callback example works. How do callbacks work, because that's the first and the most basic building block of understanding asynchronous code. And then once you understand how callbacks work, we can start moving you forward to understanding promises and then eventually understanding async await. Any questions before we end it here? Again, this will be available for playback as soon as the stream ends. I'm still keeping an eye on comments. I'll questions as they come up. Do want to mention briefly what your lab and homework assignments are. So as far as reading and such, so let's go out to perusal. Perusal's taking its sweet time to load up right now. Do I have it open somewhere? Okay. Sign in. So if you're looking at perusal once you get signed in under assignments, you'll see there's a few different reading assignments that have been posted. There's the slides that we went over today, which is part 1. We have the slides for tomorrow, which is part 2. I'll also get slides for part 3, which is Thursday. I'll have those posted as well. There's a video here that I want you to watch through. It's about an hour long, and it'll give you a good, quick introduction to a lot of things in terms of Node. So I want you to watch through that. There's some official guides that are posted. There's a few different guides here that I've kind of put together for reading. Specifically, you've got the Getting Started guide. I would read through that. And blocking and non-blocking. So those are the 2 places I would kind of start. Is those first two articles, just for today and tomorrow. So read through that. Definitely review the slides. Watch the video. NPM packages. There's some reading material for NPM packages and Express docs. We'll talk about some of that stuff tomorrow. So for specifically your reading assignment for tonight, go through the Node tutorial video by Mosh, as well as going through the slides. I think that's really all I want you to do tonight, is do the slides and the tutorial. I think that's probably the best 2 things for you to do today. Your labs are posted on Inside Ranken for this week and next. The finished product is due, I believe, let me go back to the calendar. I think the finished version of those are due next Friday, not this Friday, but next Friday. But you want to work on them as we go along. So let's see what's on the list here. So, the project to get started on between today and tomorrow is to work on the first lab, which is the portfolio website. Probably get started on the project landing page a little bit on Wednesday. This may be, I don't know if the lab schedule here is really right, so I'll have to kind of adjust it. But the expectation is that you'd work on, at least 1 lab a day. 1 or 2 labs a day. I'm going to go ahead and cut off the stream here, and I'm going to jump back over to Discord. If people have any questions or discussion, we can have that there. So I'll see you there in a minute.